The primary data types in the C programming language are the basic data types. Data types are essential in C because they define how data is stored and used in a program. In C programming, the primary data types are also called as built-in data type. Every variable must have a data type before it is used, which tells the compiler what kind of value the variable will hold, namely, for example, whole numbers, float, it can be in decimal numbers, the double, the high precision decimal numbers, and char, single characters. The primary data types in C programming language includes integer data type, a floating point data type, double data type, and character data type. A data type determines the type of data stored, how much memory is allocated, the range of values allowed, and what operations can be performed on the data. Understanding data type is fundamental because they ensure correct memory usage, valid operations, and accurate results in C programs. Now that we understand the basic data types in C, let's talk about modifiers. Modifiers allow us to fine-tune a data type to better match our needs, such as controlling the range of values or how memory is used. Think of data types like choosing a cup size for a drink. The cup is the data type, but modifiers are like choosing small, large, or extra large. You are still holding a drink, but the size and capacity change. In C, modifiers like short, long, signed, and unsigned work the same way. They adjust how much data a variable can store and whether it can hold negative values. Let's explore how these work in detail. Let's start with one of the most commonly used data types in C, the integer data type. The keyword integer, int, is used to store integer values, which are whole numbers. These can be positive, negative, or zero, but they do not include decimal points. Examples of integer values are numbers like 5, 6, 100, or even negative 2500. To use an integer in a program, we must first declare a variable. For example, if we want to store someone's age, we can write integer age. This tells the compiler to reserve memory for a whole number called age. You will notice that integers are used very often in programming for the purpose of counting, indexing, storing scores, and many other situations. As we move forward, you will also see that the integer data type can work together with modifiers like short, long, signed, and unsigned, which we will explore next. Previously, we learned that integer is used to store whole numbers. Now let's look at how we can modify integers using integer modifiers to better suit different needs. First, we have long integer. This modifier allows an integer to use more memory, which means it can store much larger values. We use long integer when normal integer is not sufficient for very large numbers. Next is short integer. A short integer may use less memory than a normal integer. While its range may be smaller, it is useful when we want to save memory, especially in large programs or embedded systems. Then we also have unsigned integer. An unsigned integer can store positive values only, meaning it cannot represent negative numbers. Because of this, it can store a larger positive range compared to a signed integer. So by combining integer with modifiers like short, long, and unsigned, we can control how much memory is used and what range of values an integer can store. This gives us more flexibility and efficiency when writing C programs. Now let's move on to another important data type in C, the float data type. While integer is used for whole numbers, float is used to store floating points number, which means numbers that contain decimal values. Examples of floating point numbers include values like 1.73 or 15.35. For example, you may also see numbers written in scientific notation such as 1.932 E5, which represents 1.932 times 10 to the power of 5. To use a floating point value in a program, we must declare a variable using the keyword float. For example, float x. This tells the compiler to reserve memory for a decimal number called x. We typically use float when dealing with values such as measurements, averages, temperatures, or any calculation that requires decimals. Later on, we will also see how float compares to double, which provides higher precision when more accurate decimal values are needed. Next, let's look at the double data type. The double data type is used to store floating point numbers just like float, but with much higher precision. This means double can store very large or highly precise decimal values more accurately than float. Because of this, double is commonly used in scientific calculations and situations where accuracy is very important. For example, to declare a variable called voltage, we write double voltage. This tells the compiler to reserve more memory so the value stored can be more precise. So remember, while float is suitable for simple decimal values, double is the better choice when you need greater accuracy in your calculations. Now let's compare the floating point data types available in C. In C, there are 3 floating point types. We have float, double, and long double. The main difference between them is precision, which means how accurate the decimal values are. To understand this, think about real-life measurements. If you are measuring your height or body weight, a float value is usually enough. Small inaccuracies don't matter much. But let's say if you are measuring voltage in an electrical circuit, scientific data or financial calculation, you are going to need much higher accuracy. That's where double can be used, as it provides the highest precision. So as we move from float to double to long double, the accuracy increases, but more memory is used. The key idea is simple. Choose the data type based on how much precision your program really needs. The following table provides complete details about floating point data types. Another basic data type in C is the character data type, char, C-H-A-R. So the keyword CHAR, or we can call it char, is used to store characters. A character can be a single letter, a number, a space, or a special symbol. Examples of characters include digits from 0 to 9, lowercase and uppercase letters like A to Z and A to Z in capital, spaces, and special characters such as exclamation mark, we don't have here, or we have a question mark, the percentage, or the asterisk. To declare a character variable, we use the keyword char. For example, char letter equals to U. It's important to remember that a character must be enclosed in single quotation marks, not double quotes. Single quotes are used for characters, while double quotes are used for strings. The char data type is commonly used when we need to store single letters, symbols, or choices, such as menu options, grades, or initials. Later, we will see how characters can also be connected to strings, which are sequences of characters. Now, let's take a moment to look at this table. So this slide brings together all the data types we have discussed so far in one place, making it easier to compare them. Here you can see the different C data types along with their typical size, range of values, and usage. This helps you understand which data type is suitable for different situations. For example, integer is used for whole numbers, numbers without decimal value. Float and double are used for decimal values with different levels of precision, and char is used for single characters. Notice how the required memory and range change depending on the data type. This table is very important because it helps you choose the correct data type when writing programs. Choosing the right type ensures your program is accurate, efficient, and uses memory properly. You don't need to memorize every number in this table, but you should understand the differences and purposes of each data type. This reference will be especially helpful when solving problems and answering assessment questions. Let's now go through this example program line by line and understand how different data types are used. So we start with the first line. We have hashtag include with the standard input or output library. So this includes the standard input or output library, so we can use printf function. And the line number 3, we have integer main bracket void. So this is the main function where program execution begins. Line number 4, we have opening bracket. So this opening bracket marks the start of the program block. Line number 5, we have integer sum equals to 100. This declares an integer variable sum and assigns the value of 100. For line number 6, we have char letter equals to capital Z. So this declares a character variable, in this case letter, and assigns a single character. Number 7, we have float set1 equals to 23.567. So this line number 7 declares a float variable set1 and assigns a decimal value of this one. For line number 8, this statement declares a variable named num2 of type double and assigns it a very large number using scientific notation. So why double? Double is used for very large or very precise decimal numbers. Normal integer or float cannot store numbers this large accurately. So what does 11e plus 23 mean? In C, the word e here means times 10 power. So the actual value is 11 followed by 23 zeros. And why we use scientific notation? The e here, when numbers are extremely large or extremely small, writing all the zeros is impractical. Scientific notation makes values shorter, clearer, and safer for the computer to store. For simple real-life analogy, think of scientific notation like shorthand. Instead of writing 11 with 23 zeros, we can just write 11e plus 23. So again, 11e plus 23 means 11 multiplied by 10 to the power of 23, and double is required to store such large values accurately. Next, line number 10. So this statement displays the value of integer variable. The percentage %d is the format specifier for an integer. Sum is the integer variable whose value will be printed, and the /n here moves the cursor to the next line after printing. We can see that the example output will be integer variable is 100 because it's already assigned to the value of 100. For the line number 11, this statement prints a single character because he used printf function, and the %C here is the format specifier for char type. Letter stores a single character like uppercase A or uppercase Z, and the /n moves the output to a new line. In this case, the example output will be character is capital Z. So the character is capital Z. Move on to the number 12. This prints a floating point decimal value. %F is the format specifier for float. Set1 contains a decimal number such as, in this case, it is set to be 23.567. So by default, the %F prints 6 digits after the decimal point. So the example output will be float variable is 23.567000, or it can be like 23.566999. For line number 13, this prints a double value in scientific exponential notation. %E here displays numbers in the form value times 10 power. num2 here is a double, often used for very large or very small numbers. So we have here double num2 equals to 11e plus 23, meaning the output will look like double variable is 1.100000e plus 24. For line number 15, we have written 0, which means written 0 ends the program and indicates successful execution. And finally, at line 17, we have a close bracket which marks the end of the program block. So now showing you how the output looks like from the code written in the code block. So the points to emphasize: each data type has its own format specifier in printf functions. If we use the wrong format specifier, the output will be incorrect. The printf function displays variable values using format specifiers that must match the data type of the variable. In this case, %D refers to the integer, %C character, %F a floating point, and the %E for scientific notation. Now, let's talk about identifiers in C programming. Identifiers are simply the names we give to variables, functions, arrays, or other elements in a program. For example, variable names like sum, age, or total marks are all identifiers. Identifiers must follow certain rules in C. They can consist of letters, digits, and the underscore character. However, the first character must be a letter or an underscore. It cannot start with a number. So this shows you the valid identifiers and the invalid identifiers. For examples, identifiers are also case sensitive, which means the lowercase a1 and the uppercase a1 are treated as two different identifiers in C. There must be no spaces in an identifier, and we cannot use special characters like alias or any other special characters. Also, identifiers cannot be reserved words or keywords such as integer, float, or return, because these words already have special meanings in C. So when naming identifiers, always choose names that are meaningful and easy to understand. This makes your program more readable and easier to maintain. The key reminder here is good identifier names make programs easier to read, understand, and debug. Next is about variables in C programming. A variable is a location in memory where a value can be stored. This value can change during program execution, which it is called a variable. Variables are used to hold data in our program, such as numbers, characters, or results of calculations. For example, when a user enters input, we store that input in variables so we can use it later. One very important rule in C is that all variables must be declared before they are used. Declaring a variable tells the compiler two things: what the name of the variable is, and second, what data type it will store. If we try to use a variable without declaring it first, the compiler will produce a syntax error and the program will not compile. When a variable is declared, the compiler allocates the required amount of memory based on its data type and ensures that only valid values are stored in that memory location. So remember, variables are essential because they allow our programs to store, update, and manipulate data while the program is running. In C programming language, the declaration can be performed either before the function as global variables or inside any block or function. But it must be at the beginning of block or function. We'll see this for example later on. So the key reminder to emphasize: if there is no declaration, there will be no variable and no program execution. Reserved words or keywords in C are special words that have predefined meanings and are understood directly by the compiler. They cannot be used as identifiers meaning they cannot be used as variable names, function names, or any other user-defined names. Examples include integer, float, return, if, while, and others. Because keywords already have a strict purpose in C, so using them as identifiers will cause syntax errors. Syntax errors happen when we break the grammar rules of C. The compiler can easily detect them, and the program will not run until they are fixed. Now, let's take a look at the codes written here line by line for declaring variables. We have float f income, float f net underscore income. So these lines declare two float variables, and we have learned that float is used to store decimal numbers, floating point. F income and F net underscore income might represent values such as salary or net income. So here, no values are assigned yet, meaning they are declared but not initialized. Next, we have double D base, D height, D area. So this line declares three variables at once. So all three variables are of type double. Double is used for more precise decimal calculations than float. They are commonly used in calculations such as area, volume, or scientific formulas. Next, we have integer I index equals to 0 and I count equals to 0. This declares two integer variables, I index and I count. Both variables are initialized to 0 equals 0 equals 0 at the time of declaration. Integer is used for whole numbers. Initialization ensures the variables do not contain values that are not making any sense. Next, we have char. Char C, CH equals to A, and another one is just C, CH2. This line declares two character variables. For this one, CCH is initialized with the character A, while CCH2 is declared but not initialized. And characters must be enclosed in single quotation marks, okay? Not double quotes. And the last line, we have a constant float f EPF equals to 0.1 and f tax equals to 0.05. So this declares two constant float variables. CONST, const, means their values cannot be changed once assigned. FEPF is set to 0.1 and F tax to 0.05. The constants are used when values must remain fixed throughout the program. In this case, for example, tax rates. Overall, this slide shows how variables can be declared individually or in groups, how some variables can be initialized immediately, and how constant is used to create fixed values that cannot be changed. In C programming, variables may be given initial values when they are declared. This process is called initialization. For example, when we write integer length equal to 7, we are declaring an integer variable named length and immediately assigning it to the value of 7. Similarly, float diameter equals to 5.9 declares a floating point variable and stores a decimal value. And char initial equals to uppercase A declares a character variable and stores a single character. Initializing variables is a good programming practice because it ensures that variables start with a known and meaningful value rather than containing random or nonsense values. This will help prevent unexpected errors during program execution. So, whenever possible, try to initialize your variable at the time of declaration. It makes your programs safer, clearer, and easier to understand. So from this slide, the key takeaway that needs to be emphasized is that initialization gives variables a starting value, which helps avoid errors caused by uninitialized data. And finally, constants in C programming. A constant is a value that does not change during program execution. Once a value is assigned to a constant, it remains fixed throughout the program. In C, we can create constants in two main ways. The first way is using the keyword constant. For example, constant double d pi equals to 3.141592. Constant integer I degrees equal to 360. And constant char sequit equals to lowercase q. Here, constant tells the compiler that these values cannot be modified later. If we try to change them, the compiler will generate an error. The second way to define constants is using the #define preprocessor directive. For example, #define n3000, #define false 0, and #define pi 3.14159. These are called define constants. They are replaced by their values before compilation starts. Constants are useful when we work with values that should remain the same, such as mathematical values, limits, flags, or configuration settings. Using constants makes programs safer, clearer, and easier to maintain because it prevents accidental changes to important values. So for constant, always remember, if a value should never change, use a constant instead of a variable. So that brings us to the end of today's lecture. Today we have covered some very important fundamentals in C programming: data types, variables, initialization, and constants. You have learned how to declare variables, assign initial values, and use constants when a value should never change during program execution. These concepts form the foundation of almost every C program you will write, so make sure you are comfortable with them before moving forward. In our next lecture, we will continue by looking at formatted input and output statements. This is where we learn how to interact with users using functions like printf and scanf, and how to display and read data properly in our programs. So please review today's slides, especially variable declarations and constants, and we will build on this knowledge in the next class. Thank you, and we will continue in the next lecture. Assalamualaikum.